have written a few conditions for constructing the 2-bit magnitude comparator. Okay, don't get confused, or I guarantee you that by the end of this video, you will understand how to construct a magnitude comparator, 2-bit magnitude comparator. Okay, let's start. Let the 2-bit numbers be A is equal to A1 A0 and B is equal to B1 B0. Okay, for a better understanding, here in this part I will give you the examples. Okay, A1 A0 and B1 B0. Okay, what is the first condition? If A1 is equal to 1, I am giving here a value here. Okay, A1 and A0. A1 is 1 and B1 is 0. Two values. Okay, it can be anything in the A0 side and B0 side. Okay, when we compare in the MSB, when this is 1, we can say that definitely A is greater than B, right? So we write here, if A1 is 1 and B1 is 0, then A is greater than B, obviously. Okay, next condition is, or if A1 and B1 coincide. A1 and B1 coincide means here we have a 1 and here we have a 1. We can put the value 0 also. Okay, I repeat, you can put the value 0 also. For the time being, in the example I am giving a value 1 here. If A1 and B1 coincide, 1 1, and A0 is equal to 1 and B0 is equal to 0, 1 1 is greater than 1 0, right? We say that then A is greater than B. A is greater than B. When A is greater than B, it's condition for greater than. Okay, how can we write the condition? See, in the first case it was A1 1 and B1 0. So we write this as A1 B1 bar plus, we have an OR condition, plus A1 and B1 coincide means A1 X NOR B1 and A0 is 1, B0 is 0 into A0 B0 bar. Clear? Next is the next condition. Okay, same example we will modify here. Okay, A1 is equal to 0, A1 is equal to 0, B1 is equal to 1, and here we can write any values. Okay, 0, say for example here it is 0 1, here it is same value, 0 1 and 1 1, which is greater? This is greater, right? So A1 is less than A is less than B. Okay, A1 is equal to 0 and B1 is equal to 1, then A is less than B. Or next condition is A1 and B1 coincide. We can again give any value, but for the time being I am putting the value for A1 as 1 and B1 as also 1. A1 is equal to 1, B1 is equal to 1, and A0 is equal to 0 and B0 is equal to 1. 1 0 is less than 1 1. Then it's also a condition for A less than B. So how can we write the expression for A less than B? See, here we have A1 0 and B1 1. So we put A1 bar B1 plus A1 and B1 coincide, A1 X NOR B1, and next one is into and, right? Yeah. So we put this as A0 bar B0. Clear? Third condition is coincidence of how A1 and B, if A1 and B1 coincide. If A1 and B1 coincide, same example, if A1 and B1 coincide, yes, coincide. They had A1 and B1 coincide and A0 and B1, A0 and B0 coincide. Yeah, same values. Then A is equal to B, right? Say for example, if we change A1 and B1 one value and A0 and B0 coincide, again it's equal. So it's A equal to B. So equality can be written as A1 XNOR A1 XNOR B1 into A0 XNOR B0. These are the expressions, okay? Based on these expressions, we have the design, okay? So these are the expressions. Please go through. Okay, next is the design. I have already written we have already derived the cases, 3 different cases, and next is about the diagram. Okay. Always the equality part, that should be drawn first. That's the easy method. Okay. We have an OR operation. We have 2 XOR operations. So we will start from from A1 and A0, A1 and B1. Okay. A1, B1, A0, B0. Sorry guys, if I'm not sure about it. In the early case, if I have not drawn this bubble mark, please make sure that there is a bubble mark, okay? That's XNOR, not XOR, okay? Okay, 2 cases. Now we have an AND operation. Okay. Now we have A1 A0 XOR case. Okay. And we have an A0, we have a B0 bar. All these cases are OR. Okay. Now we have an A1 and B1 bar. A1 and B1 bar, that is also AND operation, and both these cases are OR. Okay. Next is again the less than condition. This is the greater than condition, and we have the next the less than condition. Less than condition means we have an A1 XOR case. So what we do is okay, A0 bar B0. We can take another one. Okay, A0 bar B0. Okay, then A1 bar B1. A1 bar B1. Okay, now we have second. Yeah, just write A greater than B, that's G. Okay, A equal to B, that is E, and A less than B, that is L. Let me check the figure. Okay, if you alter the positions of A and B also, it's not, there is no issue. Okay, guys, I repeat, it's in the previous figure, in the case of one magnitude comparator, 1 bit magnitude comparator. If I have not drawn this particular symbol bubble, please make sure when you draw it in the examination, or if, for the design, if you when you are practicing it, please mark those bubbles also. Okay, in order to show that it's X now.